What if I told you that right now, hurtling through space at 50,000 kilometers per hour, there's an asteroid with a 1 in 32 chance of hitting Earth and killing 15 million people in a single day? I'm not talking about some distant sci-fi threat. I'm talking about December 22nd, 2032. That's less than 7 years from now. And NASA just declared this asteroid has the highest probability of impact ever detected in human history. 3.1%. That might sound small, but let me put this in perspective. If someone handed you a bag with 32 marbles and told you one of them would end your life if you pulled it out, would you reach in? And here's the part that should terrify you. Over 100 million people live directly in the path of this thing. Cities like Mumbai, Lagos, Dhaka, major population centers that could be completely erased in seconds. But before you panic, stick with me until the end, because what scientists just discovered about stopping this asteroid is going to blow your mind. Drop a comment right now and tell me, if you lived in Mumbai and there was a 3% chance an asteroid could hit your city in 7 years, would you move? Because that's the decision millions of people might have to make. Let me take you back to Christmas Day last year. While you were opening presents or spending time with family, a system called Atlas was scanning the night sky in Hawaii, Chile, and South Africa like it does every single night. It's programmed to do one thing: find dangerous asteroids before they find us. And on Christmas Day 2024, it found something that set off alarm bells around the entire world. An asteroid had just passed 830,000 kilometers away from Earth. Now that sounds far, right? Let me show you how close that actually is. If Earth is here, and the James Webb Space Telescope, our most powerful telescope in space, is here, this asteroid passed about twice as close as JWST. That's way too close for comfort. The moment Atlas detected it, ground-based observatories all over the planet started working around the clock to analyze this thing. And what they found was disturbing. By measuring how much light the asteroid reflects, scientists figured out it's somewhere between 40 and 90 meters tall. To put that in perspective, that's about the height of a 20-story building hurtling through space at nearly 50,000 kilometers per hour. And we think it's made of rock, which would actually be the best-case scenario. But here's the problem. We need better data to be sure, and the data we're getting keeps making things worse. Right after its discovery on January 27th, it was given a 1.2% chance of hitting Earth. Not great, but not catastrophic. Then by February 7th, that jumped to 2.3%. 10 days later, it got worse again, 2.6%. And then just a few days ago, on February 19th, it shattered all records, reaching 3.1%. That makes this the asteroid with the highest chance of hitting Earth ever detected in history. A 1 in 32 chance. And some scientists are saying we need to take this seriously, like right now. But here's what you need to understand. The probability keeps changing because we're still gathering data. Lately, the full moon has made it nearly impossible for our telescopes to even see this thing clearly. Since then, it's dropped slightly to around 2.8%, which is still higher than the previous record holder, an asteroid called Apophis, which hit 2.7% back in 2004. And get this, there's also a 0.8% chance it hits the moon instead of us. Can you imagine that? We could literally watch from Earth as an asteroid smashes into the moon. That would be the most insane astronomical event in human history. But I know what you're really thinking. What if it does hit us? If you're still watching, hit that subscribe button right now, because what I'm about to show you is the exact impact corridor, and it's going to make your stomach drop. This is the line where the asteroid could hit if it collides with Earth in 2032. Using our best simulations, we know it will strike somewhere along this corridor, and more than 100 million people live in cities directly on this line. It cuts right through Mumbai, India, Dhaka, Bangladesh, Lagos, Nigeria, and parts of Colombia. It could also destroy the Panama Canal, which handles 5% of all global trade. If that gets wiped out, the global economy would face crippling delays. We're talking trillions of dollars in damage. So how bad would it actually be? Well, it depends on two things: what the asteroid is made of and where it hits. About half of the risk corridor lies over the Indian and Atlantic Oceans. If it crashes into the middle of the ocean, that's the best-case scenario. There'd be some minimal tsunamis, but mostly we'd be okay. But what about the worst-case scenario? That's where things get absolutely horrifying. Let's say the asteroid hits Mumbai, India, because it genuinely could. On December 22nd, 2032, around 7:30 in the evening, the asteroid enters the atmosphere traveling at 17 kilometers per second. It's carrying 7.8 megatons of energy. That's the equivalent of over 500 atomic bombs. If it's made of stone, it starts breaking apart about 58 kilometers above the surface, turning into a massive cloud of rocks falling at 5 kilometers per second. Some of these rocks are bigger than cars, raining down on the city below. 40 seconds after impact, the air blast arrives. Wooden buildings are crushed instantly. Glass windows shatter for miles. About 50% of all trees in the area are flattened like matchsticks. But if the asteroid is made of iron, the story gets so much worse. The asteroid makes it to the ground mostly in one piece and slams into Earth with 5 megatons of energy. This creates an impact crater 1.3 kilometers wide and 300 meters deep. That's deeper than the Eiffel Tower is tall. 2 seconds later, earthquakes tear through the surrounding areas. 30 seconds after that, the air blast hits. These winds are so violent they destroy almost every remaining building. 90% of trees in the surrounding area are obliterated. Because Mumbai is one of the most densely populated cities on Earth, the endangered population would be over 15 million people. Even the most conservative estimates say millions would die on impact. This would be the most destructive and catastrophic event in human history. Worse than any natural disaster. Worse than any war. Now, I know that sounds terrifying, but here's the good news. Comment below if you think we should launch a mission right now to stop this thing, because we actually have the technology to do it. So when will we know for sure if it's going to hit us or not? Here's the problem. The asteroid is currently flying away from us, and after April it'll be too far and too faint for us to observe. That means we have 2 months left to gather as much data as possible. After that, we won't be able to see it again until June 2028. In 2028, it'll swing back around and pass close to Earth again. That'll be our last look at it before it potentially comes back and hits us in 2032. Because of this urgency, the James Webb Space Telescope team was granted emergency access to observe the asteroid in March. They're trying to figure out exactly how big it is and what it's made of, because that will determine how we stop it. Think about this for a second. If we were alive just 50 years ago, we would have no idea this asteroid even existed. Isn't it incredible that we have telescopes scanning the sky 24/7 protecting us? And what's even crazier, just 20 or 30 years ago, even if we did detect this thing, we'd have no idea what to do about it. But now, we have options. Some people say we should nuke it. But that's incredibly dangerous, because it could break the asteroid into smaller pieces, potentially making it even more destructive. Not to mention the political nightmare of launching a nuclear weapon into space. Others suggest using lasers to vaporize the surface and push it off course. But that technology hasn't even been tested yet. But you know what has been tested? DART. Back in 2022, NASA ran the first ever test of planetary defense against asteroids. They built a spacecraft and smashed it directly into an asteroid called Dimorphos, changing its orbit ever so slightly. It worked perfectly. And now, some scientists think we need to build another DART mission to stop this city killer. But would it even work? Let's do the math. The DART asteroid was much bigger than this one, so we'd need less force to move it. We'd have to wait until 2028 to launch, because that's the next time the asteroid makes a close pass by Earth. The collision would need to change the asteroid's velocity by just 0.02 meters per second to make sure it misses Earth. Running the numbers, if we can get a spacecraft to make a head-on collision traveling at 13 kilometers per second, it would only need to weigh about 200 to 500 kilograms to knock it off course. And that's well within our capabilities. DART itself weighed 570 kilograms when it hit its target in 2022. So we absolutely could save millions of people from this catastrophic event if we needed to. But here's the wildest part. And I need you to listen carefully, because this just happened. Since I started writing this script, NASA made brand new observations of the asteroid. And the probability has changed again. The chances of it hitting Earth have now dropped dramatically to around 0.004%. That's about 1 in 25,000. Interestingly, the chances of it hitting the Moon actually went up to about 1 in 59. But there's nothing to stress about there. If it hit the Moon, we'd be completely fine. We'd just get to watch the most epic cosmic collision in human history from our backyards. So here's the bottom line. This asteroid most likely won't hit Earth, but the fact that we detected it, tracked it, calculated its path, and have the technology to stop it if we need to, that's nothing short of a miracle. 50 years ago, we would have been completely helpless. Today, we're ready. So let me ask you this. After everything you just learned, do you think we should launch a DART mission anyway, just to be safe? Or should we wait until 2028 and gather more data? Drop your answer in the comments right now, because I genuinely want to know what you think. And if you made it this far, you're officially part of the Curiosity Beast family. We don't just explore space here, we ask the hard questions that make you think. Hit that subscribe button, because tomorrow we're diving into something even more mind-blowing. Thanks for watching, and I'll see you in the next one.